Interoperability means and looks like different things to different people, depending on your discipline or the type of data you're working with. During this presentation, I will try and separate the layers of meaning behind interoperability and help you decide where your research fits. In the context of research data, interoperability is the ability of different people, information systems, devices, and applications to seamlessly access, exchange, and integrate research data and objects for storage, processing, and analysis, to facilitate the verification of research results and the reuse of valuable research outputs, and the preservation of the scholarly record. The FAIR principles place a strong emphasis on the need for data to be readable for machines without the need for specialized or ad hoc algorithms, translators, or mappings. In a completely interoperable digital world, all data would be described, structured, and linked so as to be machine-readable and actionable, with all research outputs automatically harvestable and seamlessly integrated into the big data picture. While this level of interoperability is becoming a reality in some disciplines and for some types of data, progress is uneven, and in many cases agreed standards, infrastructures, and practices lag behind this ambition. That said, it does not mean that interoperability is beyond our reach. This is not an all-or-nothing game. All researchers can take steps to improve the interoperability of their data. And this is because when I describe data as interoperable, I am also including and acknowledging a human-centric version of data interoperability. In practice, many of the things you need to consider in allowing different systems to easily exchange and use data also need to be considered when making your data understandable and easily reusable by human researchers. George Bernard Shaw said that the single biggest problem in communication is the illusion that it has taken place. Interoperability is all about communication, so you need to make sure that your data is readable and understandable for either people, machines, or both. Which brings us to how to interoperate. Human-centric or machine-centric, or somewhere in between. The version depends on your target audience, disciplinary norms, technical ability, and expertise. As I have already said, the FAIR principles would suggest that machine-centric is the gold standard. On the ground, this is not always possible as the infrastructure, support, or expertise does not exist yet. But this does not mean you can't have interoperable data. One of the most important factors when tackling interoperability is who is the audience for your research data. Who is going to want to use your data and in what way? Research data is complex and multifaceted. Making your data easily usable for a group of your peers takes thought and consideration. As you move out from the origin of the data, the work and effort needed to interoperate increases. But if you have produced a dataset of universal appeal and value, then the effort to reach a wider audience will be rewarded. There are 3 levels of interoperability associated with any dataset or object. Foundational interoperability is the ability to send and receive the research object or data. Syntactic interoperability is the ability of a person or machine to read or parse the structure or layout of a research object or data. Semantic interoperability is the ability of a person or machine to understand and take meaning from the research object or data. Syntactic interoperability is a function of the format of the data, the software, the code. Can a person read the information in the file, or can it be parsed by a machine? It is also informed by the structure or arrangement of the data, how it is organized, or at a basic level laid out in a spreadsheet. To facilitate syntactic interoperability, it is always best to use open and widely recognized file and data exchange formats where possible, such as CSV, text, HTML, or HDF5, to name but a few, rather than niche or proprietary ones. Doing so will increase the likelihood that the other researchers will have the software necessary to open and use the data. It is also important to consider how to structure your data in such a way that it can be easily parsed by your intended audience, whether human or machine. For example, tidy data is a well-known convention for arranging data in tabular form, whereby each variable is a column and each observation is a row. It doesn't tell you anything about the variables and the observations mean. That's semantic interoperability, but it makes it much easier for others who use this simple convention to start reading and processing the data at a structural or syntactic level. The same is true, for example, of using agreed or at least documented schema, where laying out your data in XML or JSON documents. Anyone receiving the information who is familiar with that schema can quickly read and use the information. Semantic interoperability is sometimes the hardest. It is ensuring that the meaning of the data is unambiguously conveyed to a third party, either person or machine. While hopefully this table makes sense to the person collecting the data, it tells us nothing useful. The variable headings give no clue to the meaning or to the units of the measurements in the values below. A third party looking at this data will either not be able to use the data, or worse again, may incorrectly interpret it based on false assumptions. For a dataset to be considered interoperable at the semantic level, it needs to follow some convention whereby the receiver can look up and verify the meaning of each datum. Much of this comes down to the information supplied with your data and how it is presented, and the information which makes your data or object syntactically and semantically interoperable is collectively described as metadata. Metadata is data about data. It's the crucial information about your data which makes it understandable to some unknown future entity, and it is central to the interoperability of a dataset or object. Data dictionaries, codebooks, and README files are all types of metadata, but so are controlled vocabularies and ontologies and standards. Global healthcare is a prime example where establishing a universal understanding of a term or variable is critical. SNOMED-CT is a controlled vocabulary of medical terms providing codes, terms, synonyms, and definitions used in clinical documentation and reporting. Most importantly, it's internationally recognized within the global healthcare system. So, electronic health records from countries around the world using SNOMED-CT should be interoperable. For most, though, standards and control vocabularies have yet to be developed. So this means that the semantic meaning of a dataset or object is established by including a data dictionary, codebook, or README file. But as long as all elements are clearly defined, then the data is interoperable. Other metadata standards include ISO, Dublin Core, the Ecological Metadata Language. To look for others related to your discipline, fairsharing.org is a good place to start. Fairsharing.org allows you to search for technical standards, reporting guidelines, and databases in your discipline. The key thing to remember is that both the DIY option of data dictionaries, codebooks, and README files and internationally recognized standards and control vocabularies can both be read and understood by a third party, although there may have to be some reformatting, so the integration may not be entirely seamless at the DIY end of the scale. And because when it's distilled to its simplest form, interoperability is about communication. This means if you can effectively communicate your research data and it is picked up and reused, this directly benefits you as a researcher. So know who your target audience are and ensure that you have taken the right steps so your data is readable and understood when it reaches them. But also remember, this is not a one-to-one conversation. It's a one potentially complex message sent to many individuals or machines with varying backgrounds and experience, which can arrive and be picked up tomorrow or 20 years from now. So it's worth taking the time to think about how best to communicate your data, not just for now, but into the future. Thank you for listening.